Now theorem 2. The lengths of tangents drawn from external point are equal. This is the statement of the circle. Please by heart all the statements of all the theorems. They have told that there is a point P outside the circle and this is the circle. And these two are the points on the circle, so from here to here and here to here the distance will be the same. I mean PQ is equal to PR. That is what you have to prove. So the length of the tangents from a particular point drawn to the circle are equal. The lengths of the joints drawn from an external point to the circle are equal. This is equal to this is what is asked or written in the question. So now you will write the proof. Every time when you write the proof, start with what is given in the statement. Given a circle with center O, very basic, a circle with center O, and again you will write a point P outside the circle from where two joints PQ and PR are there. So a circle with center O, point P lying outside the circle, two tangents PQ and PR on the circle from point P. These three things should be mentioned in the proof. Required to prove PQ is equal to PR. What is required to prove? This is equal to this. This is what you have to prove. Construction. Join OQ, OP and OR. So now you have seen this is the statement and now you have to prove it. So what will you do? You will draw a line OP, OQ, OR. All imaginary lines. Now you will see that this is the circle, this is PQ, this is PR. This is the center O. So you know that a tangent drawn from any particular point will be perpendicular to the center. Here also a tangent which is drawn at any particular point will be perpendicular to the center at that point. So this was the theorem which we did previously. Now the same thing will come into picture. So angle OQP and OPR are right angles. This is right angle, this is right angle because this and this are perpendicular to each other. That means OR is perpendicular to PR and QP is perpendicular to OQ. See, you can see from this diagram 90 degree, 90 degree. From theorem 1. Because this is the radius, this is also the radius, this is a tangent, this is also a tangent. So this should be 90 and this should also be 90. These two angles are equal. First equal. And next, now triangle, consider triangle OQP and OPR. Consider these two triangles from the center of the circle. So if you consider the first triangle and the second triangle in this drawing, you know that OQ is equal to OR. This and this are equal. Why? Because they are the radii from the same center. So these two are equal. And then OP is equal to OP because for this triangle also there is OP, for this triangle also there is OP. So this OP and OP is common for both the triangles, so this is also equal. This one is equal, this one is equal. this the second thing is equal. So if two things are proved, there is no need to prove the third one. So angle OPQ is congruent to triangle OPR. So corresponding property of congruent triangles LHS and this angle and this angle are equal. So PQ is equal to PR. So hence this is proved.